Hello, this is the introductory video for the Colfax Developer Training video course titled Parallel Programming and Optimization with Intel Xeon Phi coprocessors. In this course, we will discuss programming models and optimization techniques for computing accelerator known as Intel Xeon Phi coprocessor. The course will focus on programming the Xeon Phi architecture in C and C++. However, most of the discussion is also applicable for Xeon processors and to programming in Fortran. This training course is organized as modules, each approximately 10 minutes long. Each module designed to deal with a single concept in programming models or an optimization technique. Therefore, you can watch individual episodes if you are interested in a particular topic, or you can watch all of them sequentially to follow the logical structure of this training. The structure of the course consists of 5 parts: introduction, architecture overview, programming models, parallel frameworks, and optimization. This episode is the introduction to the course and describes its structure and topics of the discussion. In the second part of the course, I will make an overview of the Intel Many Integrated Core or MIC architecture from the programmer's perspective. You will learn technical specifications, high-level architecture of coprocessors, and basic system administration procedures. In the third part, I will talk about programming models used with Intel Xeon Phi coprocessors, symmetric MPI, and heterogeneous calculations. And later, in the fourth part, we will quickly overview traditional frameworks for parallel programming, SIMD vectorization, OpenMP, and MPI. The goal of this part of the course is to familiarize you with the process of development with the Xeon Phi coprocessors and principles of effective parallel programming. Finally, the core of this course is the fifth part, which covers different techniques for performance optimization on Xeon Phi coprocessors and Xeon CPUs. Typically in those lectures, I will first describe the optimization technique and explain the theory behind it, and then we will take an unoptimized code and do a step-by-step walkthrough of the application, the optimization technique. The materials used in this video course are a few select excerpts from our textbook Parallel Programming and Optimization with Intel Xeon Phi coprocessors. The textbook goes into more depth about a range of optimization techniques, some of which are not discussed in the video series. Although it is not required for this video course, we highly recommend the textbook as a supplementary resource to this course or as a general reference to programming with Xeon Phi. The book is available from our website at xeonphi.com/book. I can also recommend other books as additional reading materials. The first one is Intel Xeon Phi coprocessor High Performance Programming by Intel's own experts in parallel programming, Jim Jeffers and James Randers. This book gives a brief introduction into topics in parallel programming and provides optimized code samples for high-performance computing problems. The second book is the High Performance Parallelism Pearls. First edition of this book is a collection of 28 articles written by a total of 69 authors, including 2 written by Colfax researchers. Second edition of the book will be released soon as well. Both editions cover real-world case studies of code optimization for not only Xeon Phi coprocessors but also Xeon CPUs. All 3 books come with freely available source code. The code and also all figures and diagrams are available on www.lotsofcourse.com. Finally, as a more technical resource, I would like to recommend our research website located at colfaxresearch.com. We regularly publish free research articles, case studies, and white papers about a variety of topics ranging from specific benchmarks to open source libraries. If you don't want to miss our new research publications, subscribe to our newsletter at xeonphi.com/newsletter. I hope that you enjoy the course and look forward to seeing you in Chapter 2. I also invite you to watch our interview with Intel's James Randers as an introduction to the course. Thank you for tuning in, and I hope to see you in the next episode.